Okay, so today we're going to talk about doing load calculations according to ASHRAE Standard 183. We'll be doing the load calculations with OpenStudio. This program kind of assumes that you already have OpenStudio installed on your computer and the associated SketchUp. SketchUp should come with OpenStudio when you download it and install it. So I don't think you shouldn't have to install them separately. So this assumes that you've already got that done. So what we're going to be doing here is the first thing that we'll do is create a new OSM from Wizard. And OSM is just the .osm file. That's the file extension for an OpenStudio model. And so first we need to open up SketchUp. And we will delete Steve. We don't need him there. And we go to New OpenStudio Model from Wizard. So we'll click this button, save the current model. No. It's asking what type of construction we'll be creating. For this example, we'll do an office building. We will be using ASHRAE 90.1 2010 construction set. That's essentially saying that all the construction materials for this construction template will comply with ASHRAE 2010. So for example, the insulation on the walls and the windows and the doors and the roof and etc. For this zone, for this location, I believe the climate zone is 2A. Yes, we want to create space types. Yes, construction sets, and set the building defaults using those construction sets. So we will click OK. It says the model has created 13 space types and 1 construction set, and that's based on a template, an office template in compliance with ASHRAE 2010 90.1. Click OK. It says it's saying if we want to add additional space types, then we can do that later. So, for example, if we don't have what we need in this this construction set for spaces, so we did office building, but if we need, like a laboratory or a hospital rooms or classrooms, we can do that separately. Click OK. And then the next step says go to Window, Preferences, and then save time step. Window, Preferences, General, Set Auto same time step. Windows, Preferences, General. And this sets the time step. I have it set for every 15 minutes. You may want to reduce that number or increase it, however comfortable you feel. OpenStudio does have a tendency to crash sometimes, especially if you are doing complicated modeling and you don't do something properly. So it's good to have that autosave. I personally also do a lot of saving in addition to relying on the autosave. So we'll click OK. The next step, extensions, OpenStudio Preferences, set unit system to inch/pound. So if you are working in the inch/pound system, you might want to go ahead and do that, and that's in Extensions, OpenStudio extensions, OpenStudio Preferences. Extensions, OpenStudio Preferences. And I've already got it set to inch pound. If you're going to be working in the SI system, you can select that right there. Click Apply. OK. The next step, Window Model Info, Geo-Location, Add Location. So, Window, Model Info, Geo-Location, Add Location. And for this example, we'll be working on the city of Vader, Washington, United States. So I've already got it typed in here. You can set your location wherever you're working and zoom in and out using the map. We'll select region and hit import. OK. And we'll close out of this window. And you can see that the location has been selected and imported into our OpenStudio model. The next step, Window Preferences OpenGL check. Use maximum texture size. You can uncheck this later if it bogs the model down. I found that using maximum texture size allows you to, it allows the images that you import into SketchUp to be a lot more visible. Sometimes if you have this texture size set too low, then it's hard to read the images, and you'll see how that works out later. So we'll go Windows, Preferences, OpenGL, and then use maximum texture size right here. And it's saying that it'll slow the system down, but I haven't had a problem with that. But it kind of depends on your computer. So click yes to continue. Click OK. And then extensions, user scripts, template generators, space type, construction set wizard, and add additional space types. For this example, we're going to look at this. We actually have a laboratory space here. The rest of the building will be treated as an office, but we have a small laboratory space here, so we're going to have to import an example of a laboratory from a different construction set. So we want to go to template generators, space type, construction set. So we go to extensions, OpenStudio user scripts, add on-demand template generators, space type, and construction set wizard. And this is where you go to add additional space types. Like I said, if you want a classroom or a laboratory or a hospital room, etc. So we'll click on this. And for this instance, I don't know if the other construction sets have a laboratory, but I do know that hospitals have laboratories. So we'll just add a hospital for now. Obviously, we want to comply with 2010. Our climate zone is 2A. Yes, we do want to create space types. No, we don't want to create construction sets, because we've already got an office construction set in the model, and that's what we're going to use for our walls and our windows and our floors and our roof. We don't want to import construction sets from a hospital. And set building defaults using the new objects. No, we don't want to set the defaults for this, because we already have an office construction set as a default. So really all we're doing here is importing space types from a hospital. We're not importing constructions from a hospital. So we'll click OK. Alright, so it's added the hospital space types. And I think that's all we need to do for importing space types. So then what we have to do is draw a scaling line to the exact dimensions that we have. For this instance, I've already scaled the image. You can see this down here. I've added a scale on the image to indicate just how wide the image is. So for this instance, it's 58 feet and approximately 8 inches. So this is the image that we're going to import into OpenStudio SketchUp. So what we're going to do is draw a line. So we'll select the line tool up here, and we're going to draw the line at 58 feet 8 inches. And you can see down here when I'm typing the length of the line. And this is information that you should know if you're not familiar with SketchUp. If you're not familiar with SketchUp, you should do a small course on SketchUp to learn what all of the line tools, rectangle tools, and whatnot are. So we're going to do 58 feet 8 inches. So that created our line down here. That's our scaling line. The next step is to import the image file. Into OpenStudio SketchUp. So what we're going to do here is go to File, Import, and then we will select the floor plan, and we will place the floor plan on the origin and scale it to our scaling line right here. And then you can see that our floor plan has been imported into OpenStudio. And at this point I'll just click Save and go to Desktop. We'll label this Example 1-version 001. Click Save. And it's important that you use this Save button right here. This is the Save OpenStudio Model button. You don't want to go up here and use Save, because this is just saving a SketchUp model. It's not the actual OpenStudio file. So you'll never use this to save the information. You'll always use this Save button, and this is the OpenStudio Save button. So you want to make sure to use that button. The next step is to trace the lines over the floor plan using the SketchUp drawing tools. You can select the floor plan, right click, and hide and unhide as necessary. If you want to edit hotkey shortcuts in OpenStudio, which is what I've done for unhiding information, or unhiding some of the model elements, you can go to Window Preferences Shortcuts to edit the keyboard shortcuts. So we'll go to Window Preferences Shortcuts, and I've already created a hotkey for unhiding. So unhide all, and I've created the hotkey Alt U for unhiding. So that's how you create hotkeys or edit hotkeys. And then Okay. So the next step is to trace over your floor plan. And the reason I suggested that you use hide and unhide is because what happens is when you trace over the floor plan, the image covers up your tracings. So I'll show you. We're just going to do a rectangle. We'll start the rectangle on the corner of the model, and we're going to drag it to this corner right here. And you can't see the rectangle. So what you have to do is do a right click on the image and hide the image. Now you can see the rectangle. This is the rectangle we just created, and you can see that the image covers up the rectangle. It's a little bit cumbersome. I haven't figured out how to make it such that this image doesn't cover up your geometry, but it is what it is. So you always do right click and hide to hide your geometry, and then I've got a hotkey to unhide all geometry, so we can see what we've drawn. The next room that we'll trace, you can see that it automatically hones in on the corner of the rectangle that we just traced. So we'll create a rectangle here, and we'll trace it there. Hide. You see we've traced the rectangle. Unhide. And essentially you go through the model and you create tracings just like that. And this, I'm trying to line up these two walls. So what you do is you kind of hover over a point that you want to use as a reference. See, it turns gray. Now it's homed in on that as a reference point. It's connected to the edge of the rectangle that we just created. So you know that this point that it's locked in on is immediately adjacent to that corner. So we know that these two corners will line up, and we'll create another rectangle. Oh, maybe that wasn't the best way to do it. And some of this process is just learning how best to do SketchUp. So we'll hide this. You see that this wasn't created properly. So what we're going to do is just delete this. We're going to have to double click it to make sure that not only the surface but the edges have been selected, and then we'll hit delete. And we're just going to want to stretch this up to this line here to correct that again. I just drew a line so that it knows to make this a surface again. So we're going to unhide, and we will, maybe what we need to do is do a rectangle. We'll use this as a reference point, and then we'll do the rectangle from here to this endpoint. And that way you can see that everything's lined up now. Same thing with this one. We'll use this as a reference. Turns gray. We want to use this as a reference. Well, perhaps the best solution is to draw a line. Do this to this endpoint, so it's lined up with that corner, and then we'll draw another line to this corner here, and then we'll draw this line to this corner here, and then let's hide this real quick. See if we okay. So it looks like we've got our rooms drawn properly. Unhide, and then the final thing that we have to draw is the garage. So we will draw that from that corner, and then we'll use this as a reference, and all the way to this corner here. And see See if we got it right. Okay, so we've got our storage / garage drawn. All right. So we've got our floor plan drawn in two-dimensional space in OpenStudio. The next step is to select all the floor plan line elements and then use the Create Spaces from Diagram button. So we'll just hide the floor plan for now, and we'll do a Control A for Select All, and then we use this button right here, Create Spaces from Diagram, and it's asking what our floor height is. We'll just do a 9-foot ceiling. Number of floors, we'll just do 1. Click OK, and there we go. It's created our building. The next step, double-click the spaces to edit their height and draw additional features or plenums and add windows and doors. I'm not going to go into too much detail on how to modify these elements. There's a bunch of other videos out there that show you how to use SketchUp and OpenStudio for creating funky architecture and whatnot. So, but for this instance, we'll just add windows and doors for now. Let's see. So we've got a door here, got a door here. Looks like we've got a garage door here, another garage door, window, window, door. Okay. So right here we'll just work on this window. We just need to draw a window. So it's important to double click that space that you're working on so that you will be adding the window to that particular space. If you don't double click that, then the window won't attach to the space. It'll be floating out here in the middle of nowhere. So you got to double click that space. And then it's really easy to create a window. Just click the rectangle button and the window. There it is. And you can edit the windows. We'll just delete the window. I'll show you again. Say we have a 3-foot by 4-foot window. So you can just click the rectangle button and then type in 3 foot, 4 foot, and hit enter. Oops. 3 foot, 4 foot. There we go. There's our 3-foot, 4-foot window. And I don't usually get into that much detail. I kind of just approximate it because for load calculations, a couple of inches here and there is probably not going to make that big of a difference. But if you really want to get down to it and do the actual window sizes, you can do it that way. Okay. Let's go to this side. We'll see. Let's see. We've got a window right there. We'll just do a window right here. We've got a door right there. Doors are a little bit different. If you want to draw a door, you want to start at the bottom edge. That way OpenStudio knows that you're drawing doors. And then we'll draw up like this. And we'll just make it 3 foot by 7 feet. There. It's a door. So you always have to draw, if you want to draw doors, you start at the bottom edge. That way OpenStudio knows that you're drawing a door. If you want to draw windows, you draw it detached from the edges. That way OpenStudio knows you're drawing windows. The next step, we'll go to this space here. Remember, click out and then click into this space. Looks like we've got a window right there. We're going to draw a window here. The next one on the other side is a door. For this The door is right here, so we're going to click this space, start on the bottom edge, approximately like that. And then the next, we got two windows right here in this office space. So we'll just do a window right here, window right here. And you can use SketchUp's. You can actually, what you could do is just copy that. So you double click it to make sure you select the whole thing. So if you just click it once, you're only selecting the surface. You want to double click it so you select the surface and the edges, so you're selecting the whole window component together, and then you just do a Control C, Control V, and that just copies the windows and just put them side by side. And then the next one, we have like a big garage door right here. Click it. The garage door, and then we've got a window, window, door. Window, window, door. And then we've got another garage door right here. And I believe that's it. So now we have all of our windows and doors in the model. The next step is to alter or add model elements and intersect space geometry. So this is kind of important if you're adding if you add spaces. So for this instance, we're just going to do. We'll just do a simple roof, and you know, we've already got our floor plan here, but we need to add a roof to it. Unless your building is a flat roof, if your building's a flat roof, then you can just skip ahead. But we will do. We'll just add a simple roof to this model. So what we want to do is go up here. We'll click this button, create a new space. The new space will be essentially an attic space. Click that. Then we want to double click to get into it, and we're going to trace our rectangle here. Great. And if you want to hide the other model elements, you can click this button here to hide the elements. That makes it so that you only see the spaces that you're working on at the moment. If you click out of it, you can see that it unhides them. So what we want to do is we're going to work on the roof at the moment, though. One of the things that's kind of tricky, and you'll notice what I did. You'll notice what I did was if you try to select this roof that we just created, you can't. Because it's just a two-dimensional object, and it's difficult to select. So you might have to hide some of these other spaces in order to be able to select that roof. So now we'll select the roof. We're going to edit the roof, and what we'll do is we're just going to give this some depth. We'll say maybe 6 inches. And we'll draw a line down the middle of this, and we're going to grab this and move it up. And you'll notice that we're kind of off axis. It's kind of you want to make sure if you're trying to make this symmetrical, it might be kind of hard to do. If it's off axis like this, you just hit the Alt button. And it's supposed to snap to the blue axis. Okay, now it says on blue axis, so we're on the blue axis, and we're just going to make this go up 9 feet. There we go. Great. So we're done with our roof. and then what the next tool is to intersect space geometry. And you'll notice that if we look at our roof under here, it's just one area. But in order for OpenStudio to do calculations, it has to differentiate the heat transfer between this space and the roof. And it has to delineate the edges of the walls where those spaces are. So I'll show you. You can see that this is just a flat, just a full area right now. And then what we're going to do is, we'll go up to this button here, Surface Matching tool, select it, and then what we want to do first is intersect entire model. So we'll click that, click OK. And you'll notice what happened was it created the walls. It transposed the walls from the first floor onto the attic ceiling. And that's so OpenStudio knows when it does heat transfer from those spaces, it knows what surfaces to heat transfer to in order to get to the next space. And at this point we're just going to save the model. And we're going to create a new one just in case it crashes. It's good to create additional models, versions, so that you're always able to go back and you don't lose a whole lot of work. I'll click Save. Okay, so intersect space geometry. So that's what we did on this step. And then the next step is to click the Surface Match tool. Same thing. We'll go to Surface Matching tool right here. We've already intersected the geometry. The next step is to match the entire model, and that's telling OpenStudio to match those two surfaces for doing heat transfer calculations. So click Match Entire Model. Actually, let's just cancel this. I have one more thing to explain. So we're going to select this Render by Boundary condition. And you can see right here that these are all exterior walls and exterior roofs. And you can see exterior floor right here. And they're all color coded based on what they are. The walls are a little bit lighter blue, the roof is a little bit darker blue, and we'll just select this. Right now OpenStudio is saying that, oh look, here's OpenStudio thinks that this is an exterior wall, and it thinks that this one, I'm not sure what it thinks this one is. It thinks this one is an a sun exposed, wind exposed outdoor ceiling. So it's all kind of messed up. We'll click these. It still thinks that this surface is an outdoor roof or ceiling. But what you can see that, and you see that OpenStudio thinks these walls are outdoor walls. So what surface matching does is surface matching matches up. It makes a determination on what walls are exterior walls, what walls are interior walls, and what walls are adjacent to other spaces, and it tries to figure out what the heat transfer characteristics will be between those different spaces. So let's do this. Let's match entire model. Click OK. Okay, and so we will see how we did. Okay, now so you'll notice that the interior spaces are now interior, or I'm sorry, the ceilings are now interior ceilings. There's no sun or wind exposure. This is showing it as a floor because yes, it is in fact the floor of the attic. And you can also see that the ceilings on the first floor are all interior now that they're green. So the next step is to select a space and set its attributes using this selected space button. Assign space types to all the spaces, and then you can rename the spaces. So we'll select this space first. This is going to be our garage 6. So we'll call it garage 6. Garage 6. And then we'll use the Set Attributes for Selected Spaces button. And we're going to change the space type to storage, office storage. We're not changing the building story. We're not changing the construction set. We're not changing thermal zones right now. And we'll just leave all the rest of this on default, no change. Click OK. And then we just go around and do the same thing for the rest of the spaces. This is electrical 3. We're going to change the space type to office, electrical, mechanical. Click OK. This is the lab. Lab 1. Lab 1, and then we're going to change this space type to, we had to bring in the hospital space types because the hospital has a lab template here, so we'll do the lab here. We'll click OK. And then this space is the restrooms, rest 2, we'll set the attributes as an office restroom. Click OK. And then this space right here is a hall. We're going to call it Hall 2. Hall 2. And we'll set an attribute as an office corridor. Click OK. This is an office. We're going to call it Office 4. And we'll set the attribute as an office, closed office. Click OK. And we've already got the garage. And the only other one we have left to do is the attic. We'll call this attic. And we're going to just assign this as a storage, office storage. Okay. So that now that we've reassigned all the spaces, we can check it. We'll select. We go into the OpenStudio inspector. We can look at. We've got spaces: attic, electrical, garage, hall, lab, office, and restroom. So we've got all the spaces assigned. The next step in the process is to add thermal zones to those spaces. And to do that, we can use one of the extensions to automatically add thermal zones to all the spaces that don't currently have thermal zones. If you go into the inspector, you can click thermal zones and you'll see that we don't have any thermal zones assigned yet. So go up to extensions, user scripts, alter or add elements, and add new thermal zone for spaces with no thermal zone. So we'll add a thermal zone for all those spaces. and it's done. You can now see that we have 7 thermal zones assigned to the 7 spaces. This it says rename the spaces according to the floor plans. We already did that. And then the next task is to rename the thermal zones based on the space names. So and that's another script that's already created for us. OpenStudio user scripts, alter add model elements, and rename thermal zones based on space names right here. And that'll rename all of our thermal zones from the generic, because right now you'll see that all of our thermal zones just have a generic name to them. But it's easier later on to have those named according to the spaces. That way we know, we can see what the thermal zone is serving. So rename thermal zones based on space names. Click OK, and then we'll select thermal zones over here, and you'll see that they all got renamed to include the space name in them. We did that. The next task is to select spaces and groups by type, and then set the attributes for the selected spaces, fill in the info, the space type, and thermostat type. You may also use this dialog to combine thermal zones into one. So we don't have any combined thermal zones at the moment, and we can use a filter up here to look at these spaces by thermal zone. It's this button right here, render by thermal zone, and you can see that OpenStudio colors the thermal zones different colors based on how they're separated. And we'll just hide the attic for now, and you can see that the thermal zones are all different colors. What we're going to do is combine this hallway and this office together into one thermal zone, just so I can show you how to combine thermal zones. So what we'll do is we'll select this, we'll hold down the control key and add the hallway to this, and then we'll select the set attributes for selected spaces button, and we're going to change this thermal zone to office 4. So it's we already have the office on office 4. We're going to just add the hall to office 4 with this action. We'll click OK, and you'll notice that now the hallway and the office are on the same thermal zone. And now that we have the hall and the office on the thermal zone, we don't have any use for this hall thermal zone anymore, because the hall was added to the office. So what we're going to do is just delete this hall thermal zone right here. And now we've got those two spaces on one thermal zone. Let's see. And then select spaces and groups by type, set attributes for okay, we already did that. And then we already removed any unused thermal zones. Like I said, that hallway was an unused thermal zone, so we just removed that. Select specific windows and then extensions. Add overhangs or projections. So this is a script in OpenStudio that you can use to add overhangs over the windows. We'll just change back to construction here. OpenStudio user scripts, alter or add model elements, add overhangs by projection factor. And then so this adds overhangs by projection factor over the windows. You can change these values based on what your construction is. We're just going to leave those as default right now and click OK. oh, we have to select the windows. So we can double click, select the windows, extensions, user scripts, alter add elements, and add overhangs, and click OK. So what it did was it just added an overhang over the window, and you can do that for all your windows and doors. This we're just gonna delete this. Right now, and this particular building actually has it just has an overhanging roof. So I'm going to show you how to do custom shading for this, and we'll just do a simple overhang around the entire building. So what you do is you go up here to New Shading Surface Group, and click it. And then you're going to just locate it anywhere on the model. It creates a new shading surface group. We'll double click to enter it. And what we're going to do is we'll just draw a rectangle from this corner to this corner. And then what we're going to do is an offset rectangle from the existing one we have. And it has a 2-foot overhang, so we're just going to type in 2 feet here. Click that. And then we're gonna select. Oops. We're gonna select this interior surface, and we'll just delete it. That way, we just have shade on the outside edges of the building. So there's our shading. There's our custom shading. And at this point, what we'll do is we'll save the model and create a new version, just so that if anything goes wrong, we can always step back to the previous work. Click Save As. Yes. So that's how you do custom shading. And this is custom shading. And then at this point, you can rotate the model to account for your true north, and you might actually have to reinsert the geolocation back into the model. So what we could do, if you go to Window, let's see, Model Info, Geolocation. Clear location, add location, and select region, and then we'll just re-import it. And well, you see it got re-imported into the model. And it's backwards here. So this is north. You'll notice that the green axis is pointed approximately towards the north, and this building is actually rotated on the axis by 60 degrees. And I think it's supposed to be facing these 2 streets approximately. So what we'll have to do is just rotate it. So we're just going to do a Control A to select the entire model, and we'll use the rotate button, use the origin as the pivot, we'll use the red axis as the lever, and then we're going to just rotate it, and we'll type in 60 for 60 degrees, and then click Finish, click Enter. So now we've rotated our model by 60 degrees. And this way, OpenStudio and EnergyPlus can do the correct solar exposure when you do the solar exposure. I mean, when you run the simulations, it'll do the correct solar exposure. So we'll click Save, save the model, and We've rotated it, reinserted geolocation. And then at this point, you can create adjacent buildings, trees, etc. by clicking New Shading Surface Group, just like we did with the shades. And you can use the geolocation as a reference, and you can trace that location image prior to editing the shading group. This image is not. Let's see, this is just a street map, so potentially what you could do, I've seen before, is see, clear location, add location. You can change, let's see, you should be able to change from a street map to a satellite view, but apparently I can't see that on there. But if you have other buildings, essentially what you're doing is you're adding a shading surface group. If these buildings are really large buildings, then they're going to affect your daytime solar exposures, like in the morning or in the afternoon. You can add those. So what you do is just create a new shading surface group up here with this button. You can click it anywhere on the surface there, double click, and say we had like a great big skyscraper here. We'll say it's maybe 60 feet tall, and so in the afternoons, late afternoons, this building is actually going to be shaded with by this this larger building next to it. You can do the same thing with trees. One of the things they suggest is to delete some of these surfaces, so it takes less strain on when you're actually running the calculations. That way, EnergyPlus doesn't have to calculate all these extra surfaces. So you could potentially delete some of these surfaces that are not, they won't affect the shading of the actual model. And we'll save the model. And okay. And then if you wanted to see a simulation of that shading, you can click Window, Default Trace Shadows to see and simulate what those shadows would look like. So Window, Default Trace Shadows. Window, Default Tray Shadows. And you can change the, let's see, yeah, you're supposed to be able to adjust the shadows. Oops, use sun for shading. Okay, so you can kind of see what the shadows would look like. Let's take a look at this in the winter time, maybe in the evening. So the shadows don't make a big difference. And And this, I think this is, well, let's see. I'm not sure. Anyway, there's a lot more to it than I understand, but and there's more videos out there that kind of describe what this shading effect is. But the gist of it is you can create adjacent buildings and other obstructions that create shading on your building and might affect your heating and cooling loads. Okay, and then at this point in OpenStudio Inspector, we can purge any of the unused objects that we didn't use in the model. We're essentially done modeling the model at this point. So what we can do is we'll go into spaces. Let's see, we've used all the spaces. Oh, I'm sorry. Okay, space types. So we've got a lot of extra space types in here. We didn't use hospital corridors, dining, exam rooms, or any of that stuff. And we don't need that, and it just clutters up the model. So what we can do is just click this button, Purge Unused Objects. And it pretty much erases everything that wasn't used in our model. We'll click Save. And then one final thing is we need to name our building. Probably should have done this in the very first place, but that's okay. We'll just call this Vader WWT building. And we'll save the model. Okay, we're going to save it, and we'll save another version of it. Save version 5. Click Save, and then at this point we're going to open up OpenStudio. So you use the Launch OpenStudio button, which is this button right here. And it opens up OpenStudio. And it automatically brings in the OpenStudio model that you created using SketchUp. We're going to set the preferences units to English IP. So we'll go to OpenStudio. Preferences, units, make sure this is set to IP, or if you're working in metric, you use SI. We'll select the appropriate weather file and design day files. So OpenStudio uses two different files for running calculations. The weather file is a full year weather file. It's a typical meteorological year for the entire year for that location. So we'll use Toledo Windlock. It's an EPW file. That's what the weather file is, and you can download those off of the EnergyPlus website. Click Open. Design day file, you'll have to select the design day file from same place. It's a DDY file, and like I said, you can get those DDY files from the EnergyPlus website. We'll do Kelso. This particular, they didn't have weather file for Kelso, but they have design days for Kelso. We'll click Open. So the design days are the most important, and these are what are going to determine your peak loads for the purposes of load calculations. So it's important to have the correct design day file, since that's all we're doing right now is load calculations. And the next step is to select Schedule tabs, Schedules, and I do this by default automatically. We'll go to the Schedules tab. Well, we can fill out this too. Climate zone is 2A. It's 2, I guess. And we'll save it. We'll save the model. The next step is to go to the Schedules tab. That's this tab right here. Click on it. And by default, I always just add a typical exhaust fan, on-off exhaust fan, because the model doesn't incorporate exhaust fans. We'll click Add. Oops. Oh, let's see. No, we don't want that. We'll just delete this. We actually have to go to the Schedules tab up here, and then we'll do Add, and it's just going to be on off for an exhaust fan. Click Apply. We're going to call this exhaust fans, and you double click where you want to make a break, and so it's going to be off during the nighttime, and it'll run most of the day, and then it'll turn off say 5 in the afternoon. That's how you create a schedule. It's pretty simple for exhaust fans on off. And then the next step is to select Thermal Zones tab, HVAC Systems. And so we'll go to Thermal Zones right here. It's this tab. Click on Thermal Zones. And review to ensure that all spaces have thermostat schedules applied. And then add exhaust fans to zones. So what we want to do is add zone equipment. Well, we'll add zone equipment first. We say we have a exhaust fan in the restroom, and so we'll do zone. Let's see, zone exhaust. So we'll go over here to the Library tab, go down, Fan Zone Exhaust, do Zone Exhaust Fan, and we'll just drag this over to the restroom, and we'll just drop it right here. Now the restroom has its own zone exhaust fan. We'll click the zone exhaust fan, and we'll say it's 80 CFM and an 1/8 inch of static pressure. The rest of the zones don't have any equipment associated with them, but we do need to add some thermostats. So we have to find the office schedules. Schedule rule sets. Large office building. So we're going to do small office building cooling set point. So we'll just drag this cooling set point here. Small office building heating set point. Drag it here. And the rest of it can get more complicated if you've got humidification or dehumidification. But for this project, for simple, sensible load calculations, we'll just worry about these at the moment. So what we do, we'll have to apply these to all of these. If the spaces have different set points, it gets a little more complicated. You'll have to add an additional schedule. But for a small building like this, we'll just keep it simple and have the same set points for the space. So we'll select this. And then what you want to do is you want to select all of the other ones that don't have the thermostat schedule yet, and with the check marks, and then you select small office cooling set point and apply to selected, and then small office heating set point, apply to selected, and you'll see it applied all of those set points to those other spaces. And we can save the file. So we've done this. Select thermal zone tabs, cooling sizing parameters, and adjust those as applicable. So we'll go to this tab right here, cooling sizing parameters. We're going to just set all of our supply air temperature to 55 if that's what your design conditions are, and apply to selected. And then you can adjust all of these other parameters to design supply air humidity ratio, and all of these. One of the items that let's see, airflow, sizing factors. One of the things that you might want to adjust is the air distribution effectiveness, and this is based on the ASHRAE ventilation rate procedure. And if you've got, we'll say we have overhead supply and return air distribution, so the ventilation effectiveness is going to be 0.8, and we'll apply that to the rest of those. Let's see, for heating, sizing parameters, we'll just say our supply air temperature is going to be 90. I don't know why it defaults to such a high temperature, but that could be just by using residential equipment or something. But so we'll apply to selected 90 degrees supply air, ventilation 0.8, apply to selected. Okay, distribution effectiveness, and save the model. Same thing for heating. And then the next step is to select the Measures tab and select Reporting drop down, and drag in the OpenStudio results. If you don't like, well, let's see. We'll start with that. So you go over, you select the Measures tab, go over here to Library, Reporting, QA/QC, and you might not already have this. You might not already have these files. So what you have to do is find Measures on BCL button down here, and you should have set up the BCL link when you set up your OpenStudio, but if you didn't, there's documentation and other videos out there that describe that. So we'll select this, and it opens up the BCL online database, and we'll go to Reporting, QA/QC, and we'll just search for OpenStudio. And what you want to look for is OpenStudio Results, which is this one right here. You can see I've already got it downloaded with the check mark, but what you would do is just check this and then click the download button, and then you'll suddenly have OpenStudio Results there. So we'll just grab the OpenStudio Results, drag it over here to the Reporting Measures, it's suddenly in there. And then what you can do is run the model. Run the simulation. And we'll just hit save first. So then we'll go down to here, the Run Simulation tab, and click Run Simulation. And it could take quite a while depending on how large your model is. One of the things I forgot to mention was at this point you can also go back and purge some of the unused information that we have in our model. So if we go back to schedules, schedule sets, and you'll notice that you'll see all of these hospital schedule, corridor schedules, dining schedules. Most of these schedule sets we didn't use any of them. So what we're going to want to do is just purge them purge the unused objects. We'll just click this button, Purge Unused Objects, and you'll notice that some of the things were retained, like the lab schedule, because we did use the lab space, closed office, corridor schedules, storage schedule, okay. So we've got all those still remaining. The other thing that I did forget to do is for this zone exhaust fan, we need to assign the exhaust fan schedule to it so that it does turn on and off according to that schedule that we created. So we'll just go over here to Schedule Exhaust Fans, and we'll click Save, and go back to reporting. Oh, run. So we'll run the simulation again. Should go a little bit faster since we purged some of those items. And it's finished, completed, it was successful, and then you go over here to Results Summary tab. It automatically opens up the OpenStudio results, and you can go through all of this information and see what the peak loads are, zone equipment detail. One thing I forgot to do was set the ideal air loads for these thermal zones. So we'll have to go back to the thermal zones tab and turn on ideal air loads for all of these spaces. And this will, okay, that got rid of our exhaust fan. But you can turn on ideal air loads for all the spaces. And this way EnergyPlus will run through a simulation making a determination on what the ideal loads are for the space, and it's not taking into account equipment performance or combining zones or adjacent zones during different peak times of the day. So this will be a worst case scenario peak design loads, and that's essentially what ideal air loads are. So we'll go back down to we'll go ahead and save it, down to run simulation, run it. And then we can go to the reports, results summary, OpenStudio results, and go to zone overview. And this time you'll notice that it did come up with some loads for each of the zones. Let's see. Okay, right here. Sensible cooling and heating sizing. So this is the calculated design load, and here's the design load with your sizing factor involved, and that's for cooling, for heating, cooling, heating for each of the zones. So this is, like I said, this is worst case scenario. This is peak load for all of the zones at any particular time of the day or of the year, and it's not exactly representative of the total building load during its peak load, and that's based on solar exposure and occupancy and all those other factors as well. If you want to do a quick and dirty design load calculation, what you can do is just go back to thermal zones, and we'll turn off ideal air loads for all of these, and you can just add a package terminal air conditioner for each of these zones. So we'll just add this as zone equipment, and we'll apply that to all of the other zones. Apply to selected. It created PTACs for each of the zones, and at this point we might as well go back and add our zone exhaust fan to that restroom. Right here, edit it. Schedule is exhaust fans that we created, 1/4 inches static, 80 CFM, and we can save the model and go back to run simulation. It was successful. We'll go to reports and zone overview and design loads and calculated design loads, and then at this point it actually shows you zone equipment selection. So an equipment selection for each of the zones that we assigned it. Previously, when we just did ideal air loads, there was no zone equipment. But this time, since we added PTACs to each zone, it shows equipment selection for each of these zones. So, and finally, if you want to print out the report, what you can do is go to your OpenStudio model file location. We're working on version 5, and you can open up the version 5 folder right here. It should be in the same location. You go to reports, and you can open up OpenStudio results report in your web browser, and just go ahead and hit print, and you can print that out as a PDF or whatever file you want, or it's an it really is an HTML file. If you want to keep it as just an HTML file, you can do that too. One of the things that I should point out at this point, OpenStudio Results is pretty good. It's a fairly down and dirty, almost comprehensive results about your model. But the EnergyPlus results themselves, if you go up here to the right, or up into this corner and click EnergyPlus results, it's a little bit more comprehensive than the OpenStudio results. Unfortunately, it defaults to metric units. You can go to the table of contents over here, click that link, and it's got a significantly more information than the OpenStudio results have if you're trying to troubleshoot the model. But as I mentioned, the EnergyPlus results comes out in metric system by default. EnergyPlus does all of their calculations in metric, and then at the very end they convert to the English system. So if you want to change your EnergyPlus results to the English system, you can't run the OpenStudio results as well. So you'll have to delete those, go to Library, Reporting, QA/QC, and then if you the measure is called Set Output Table to IP Units, and you may have to search for this on the BCL. But if you select this, bring this over here, this will print the EnergyPlus results out in IP units. Unfortunately, you can't add the OpenStudio results because the OpenStudio results are expecting an input of metric units, but at this point the output is IP units. So anyway, that's the short of it, and then you just go ahead and run the model, run the simulation again, and you'll get your EnergyPlus measures in IP units. So we'll go ahead and run this simulation again and see what it looks like with the EnergyPlus output as IP units. Successful. And now you can see that the EnergyPlus units are in IP English system. And you can go to the table of contents and look at any number of factors that affect your building, loads, lighting, people, HVAC sizing, etc. So that pretty much concludes the simple load calculations using OpenStudio. And if you like this video, please give me a thumbs up. Thanks.